Hi, my name is Celia Khanna with Marine Technology TV, and I am here today with members of the ROV team from the CCGS Amundsen. Thank you guys all for being here today. Would you mind each introducing yourself and telling me a little bit about your role and what you do?
Hi, my name is Barbara Neves. I work as a research scientist for Fisheries and Oceans Canada. I'm based in St. John's. I work mostly on deep sea fauna, deep sea corals, and I do a lot of the ROV work to try to get some images of the seafloor and collect samples and that sort of thing in the Amundsen.
I'm Gabby Inglis. I work for Amundsen Science. I'm based in Quebec City. I am the project manager for the ROV ASTRID here, and a technician. That means that I am the technical specialist who makes sure that the ROV is ready to go and make sure it operates properly during expeditions.
I'm John O'Brien. I'm a research scientist with the Department of Fisheries and Oceans as well. But I'm based out of Winnipeg, Manitoba, and I'm with the DFO's Arctic region. So, like Barbara, I'm mostly involved in studying these sensitive deep sea ecosystems using the ROV as a tool, um, primarily deep sea corals and sponges. And the areas that I'm more focused on are three protected areas in the Eastern Canadian Arctic that are called marine refuges.
Amazing. Thank you all for being here again. We have a nice cross-Canada representation today. I'm based in Halifax, so it's great to see how many provinces we can we can cover on one call. Just to get us started, would one of you be willing to talk to us a little bit about what the vessel itself, and then more specifically about the ROV on board, including any specs that you could share?
The ROV is made by a company in the UK called Forum Energy Technologies. It's an ROV. It weighs about 1.5 tons. It is rated to go to 2,000 meters of depth. The way we're currently set up, we can go to about 1,600 meters, just because of the length of tether we have on board. One of the cool things about this ROV is that it's got a very small footprint, which means that we can put it on various vessels, including small ones. The winch is small, the ROV is fairly small, so it makes it a very flexible system. It also has between 1 and 2 arms in the front of the ROV that allow us to take samples and manipulate things that we find in the environment. And it has a set of sample drawers that we can place samples in. So we can take things off the seafloor and bring them to the sea surface and onto the ship for the scientists to use. It's all in all like a very capable system. We're constantly making upgrades, lots of repairs. Yeah, it's a pretty cool system. It's pretty capable.
About the ship, I can say that it's a Coast Guard vessel. It is an icebreaker. As the name says, it can break ice. So it can really go to the Arctic and even when there is a lot of ice in the ocean. So that is very nice for us to access these kind of areas. The ship, I think it's about 100 meters long. So that is, a relatively large ship. And we are usually 80 people on board, around 80. So you have maybe half of those are Coast Guard people, the crew, and then you have about 40 scientists from all over the place, like from all over Canada, from outside of Canada as well, doing many different types of research. So the ROV is one of the machines we are very interested in, and that's what we're discussing today. But there's a lot of other types of equipment that can sample seawater, can sample sediment on the seafloor, can map and do so many things. So it's a very interdisciplinary, ship in this sense. You have all of this going on.
On top of the pool of equipment for sampling, there are fairly extensive laboratory facilities, both like internal labs, and then there are a number of spaces like on deck with, where like a CCAN have been modified for specific types of analyses, or like there's a dedicated mooring lab and an electronics lab. So there's all of the infrastructure there for a wide range of different scientists. As Barbara mentioned, up to 40 scientists to do very diverse types of interdisciplinary research.
Also, I would add that life on board is pretty nice. It's the best food I've ever had at sea. it's a great ship to work on.
And on that, like John mentioned, the labs and that sort of infrastructure. There is also the social areas of the ship, right? So when we go, we usually in the past few years we have been going for a whole month. So you need to think you living in the ship, right? And so that is also important. So there is the labs, and there is also the social areas where people can socialize.
I want to look just really briefly kind of at the management and deployment of the ROV. So, who coordinates what, who makes the decisions? Because I know there's, as you've all said, there's a ton of scientists on board. There's a lot of projects going on. So I was wondering if we just get some insight into that process.
I can start. So managing the ROV has sort of two halves to it. One is what happens when it's in the warehouse right here. I think you're probably more interested in the part that actually happens out at sea, which is, I would call it operations as opposed to maintenance. So during operations, like the ROV team itself is usually 4 or 5 people. And we keep the ROV running when we're out at sea. It always needs repairs. It needs constant checks to make sure it's going to perform well. And then it needs to be operated. So that's the ROV team of 4. But we often say we just drive the bus. We also keep it running, but our job is to follow direction from the scientists. So our initial direction comes from Barbara and John. And then we work with the ship's crew once Barbara and John have created a list of their requirements for the dive. We work with the ship's crew and with the scientific leads to look at the weather, look at the risk factors, look at the vehicle's capability and where our crew is at, and the scientists' needs and constraints that day to actually formulate a plan.
Yeah, so we do this, we go through a process, a ship time application, where scientists, any scientists pretty much, could apply to request for time in the Amundsen, right? So that is how it begins. And then Amundsen Science, they will make a decision of who is going to be coming. The different scientific groups will come for the different legs in the expedition for a given year. And so it begins like that. So in this year, for example, we have for leg 1, myself, John, and a lot of other scientists are interested in the ROV work. So we work together, right? So like I said, we need to put an application to get in the ship, and we do that as a group too. So we are very connected, interconnected in the different research we do. And so pretty much now that we are prepping for the expedition, we're going to begin to have discussions about, okay, the different teams have these objectives to attain during an ROV dive, and who's going to be doing what. And so we're going to have this, we call a dive plan, where we're going to have a list of objectives, what we're doing at each dive, where we're going, at which depth, are we collecting samples, are we deploying an equipment, what are we doing, that sort of thing. So that's sort of discussions that are pretty much ongoing now with our teams. So during the dives, you're going to have Gabby and the others in the ROV team that are manning the equipment, that are driving it. And, like she was saying, well, we're just driving the bus, but I mean, they're very critical to this, really, because we can't do this without them, right? So, that is the part where you're going to have the ROVs in the water is collecting data, and then you have the scientists in the room directing and saying, well, I would like to do this and do that and that sort of thing.
I guess I would just add that there's quite a bit of advanced planning involved, as you can imagine. So as the kind of scientific personnel put together the scientific objectives of the mission and identify dive sites and put together dive plans, this is all happening months and months in advance with lots of back and forth conversations. And I would also say that there's a high degree of collaboration, not only within the scientific team, as Barbara mentioned, in terms of making sure how we can align our objectives better to achieve the most in the limited dive windows that we have for the most people, but also that really close work between the scientific team and the ROV team, and the ROV team and the ship personnel, the Coast Guard. And I would highlight that there's a lot of input that we, as like the scientific personnel, get from the ROV team as we kind of draft the specific dive plans, getting input, whether what we've outlined is reasonable, or feasible, or how can we make it happen. If there's specific equipment that needs to be adapted or constructed in order to kind of make our dreams and visions about what might be possible come to life. We work really closely with the RV team to make that happen. So collaboration is definitely key.
That was my next question as well, was about the collaboration. So I'm glad we kind of got that all together. It sounds amazing, how much work goes into it. And, touching on that, given you all have experience, with the ROV and on the vessel, could you each highlight, a project that you've been a part of with the ROV that stood out to you, whether it was just, a first time interacting with it, which was super cool, or if it was your own research, just, kind of give us some insight into the different projects you've worked on and, what's stood out to you.
I'll do a couple because I can speak directly to what John is talking about with the collaboration. So, and to sort of highlight how long this takes. Several months ago, I began working with one of John's technical staff. She had an idea for how she wanted to conduct an experiment. She wanted to construct a piece of equipment. She came to me and she's like, "How should I construct this equipment that so that it'll fit on the ROV? I want to take this many down on this dive. Let's make sure it fits on the ROV. Let's make sure it's got the right weight, the right buoyancy, and the right handles and grips on it so that the ROV can pick it up." She and I did a number of iterations on that project, and we're sort of getting down to the final iterations. She'll send me a drawing. I'll tell her, maybe change this. She'll be like, "Actually, we need to do this for the experiment." And we go back and forth. And it's a really fun part of my job to work with scientists to help them come up with new ways to do things. In this case, I believe it's an experiment that's been performed before, but sometimes we're creating entirely new pieces of equipment that have never been used before. And then actually bringing them out to sea is really exciting. Like, it's a bit nerve-wracking. You're like, is this thing that we spent so much time on, is it going to work? Is it going to fail on the seafloor? And then the scientists don't get their data. Like, it feels kind of high stakes, but that's exciting. And then you get some data back, and that's really great. And then the other part of this that's so much fun to do is just like see things that so few people actually get to see and share them. So I loved last year we went to the Hanging Gardens at Makovic, and that was live streamed, and that goes out to communities who know the terrain really well, but get to look at it in a new way. And it's just really beautiful to look at coral gardens and be able to share that with people. That's always a super fun part of creating ROVs.
I can jump in next and highlight a project that we began last year, and we're going to continue this year, and also with a lot of involvement and input from Gabby and her team. So last year we used our ASTRID to deploy a new study on growth rates and reproductive capacity of a sponge called Geodia. So these sponges form really dense aggregations in the deep sea, and they have the capacity to filter incredible volumes of water. So they're really tightly and play a really large role in nutrient cycling in the deep sea. And unlike deep sea corals, or some deep sea corals that produce annual growth rings, it's a bit more challenging to be able to measure growth rates in age sponges. So we had an idea for a study that would be kind of a long-term play where we're using ASTRID to deploy kind of unique numbered tags beside individual sponges on the sponge grounds, and be able to return to those same individuals, years down the road, and be able to assess the rates of growth. And then from those kind of relative growth rates, be able to do some kind of backtrack calculations of the relative age. We also, with the input of Gabby and her team, designed these kind of sponge coring tools. So in order to get an idea of the kind of reproductive capacity of these sponges, we need tissue samples from them, but we also want to be as minimally invasive as possible and not, remove whole sponges if we can avoid it. So we use these kind of sponge cores to take cross-sectional tissue samples using the manipulator arm of the ROV. And so the benefits are we can use those tissue samples to look at, how much these sponges might be reproducing. The sponges themselves can regenerate tissue. So there's the benefit there that we don't have to remove individual sponges. So we had some proof of concept on a dive last year, and we're going to continue to do some of the same work this year.
Yeah, so the favorite projects, I think one thing that I've learned over the years working with the ROV is that it is a very powerful tool. It's also a very complex tool, right? We need to have good weather or better weather than for some of the other operations and things like that. And so it is really, I like to think of it as what can this tool do that others can't, right? So thinking about this example that John just gave, you cannot do that. You cannot go to depths over 500 meters. We're not talking about scuba diving depths. So we're going deep water. So without a robot, right, that can do that for you, that has an arm and that can do things. So for me, it's also that sort of project that is very interesting. I will highlight that and some of the discoveries that we've made also based on that. So one year we did an experiment where similar type of questions as John, as in growth rates, but it was for coral. And pretty much we went down with the ROV and we created this chamber. And then we put the chamber on top of the coral and then we released the stain so that we could create a little mark on the corals and then go back a few years later to see that mark and then estimate, the growth rates and that sort of thing. And so that was really, really cool. And then the same year we went down with a trap, like you could think of to trap a crab underwater, like fishing, right? And then we fit that in the ROV and we went down and then we opened the trap exactly on a spot that we wanted on the seafloor. So it's something that you could not just, throw that over the ship and then it's going to fall exactly where you need, right? So we needed to be very precise. And so the ROV can go with the arms and then just place it exactly where we need it. And that sort of thing, I think it's really fascinating and really helps us with our work. And then the discoveries, I think the most recent one is, Gabby mentioned it, we call them the Makovic Hanging Gardens. We're talking about a coral garden. So that is a site off Labrador at about 600 meters, 700 meters. And where in 2021, we saw underwater images with the ROV for the first time. Very, very dense cover of corals on a cliff, right, on a wall. So you also would not be able to do that without the ROV in the same, like with the quality that we could see them. So yeah, I think these are some of my favorite ROV moments.
Amazing. Gabby, I think you have something for show and
Yeah,
tell.
I have a show and tell. I have the coral staining or the sponge staining chambers that were designed. This is another great example of like the projects that we go back and forth and work on with the scientists and get to create something and then get to deploy it and see how it works.
It's great to hear about all the stories. I love the show and tell as well. It's awesome to get to see the tech and then also, the additional resources up close. Barbara, you mentioned that, the ROV can be at times, it's a great tool, but it's also one that requires very, exact conditions to work well in. And so I was wondering if, any of you have any challenges that you run into with the ROV, whether, common challenges or just, an experience where, you were in a tough situation and, had to figure it out with the ROV. So just kind of any insight on any challenges you guys have run into over the years.
ROVs are really challenging. That's why it takes a big team of people who have lots of experience to run them. They're just challenging. I think one specific to this crowd is it's always exciting to approach John's sites because John likes to operate in high current, which is where sponges are. But ROVs, especially one like this, can operate in about a knot of current, and that's really pushing it. So we start to get into these areas where we have to be very careful about what conditions we deploy in and keep really close track of the current. And then when we're on the bottom, we have to keep close track again, and we start to operate in conditions that are very close to the edge. So that's always pretty exciting and challenging to try and work with and around to try and make sure that John and his group get all the data they need. And we're always making concessions. It's always a compromise. It's yes, we'll go. It's high current. We're not going to get all the work done we want. Maybe we don't get to every site. But we definitely always want stuff to come back to as opposed to okay, we did it all. Now what? It never comes to that. There's always more. So yeah, that's definitely something that will come up again this year.
That's the bit of the conundrum that we are in, Barbara and I, in that we are studying deep sea corals and sponges, and they just happen to love to live in areas with really strong currents that are very challenging for the ROV to operate. And one of these areas in particular is one of those protected areas, these marine refuges called Hatton Basin, which experiences very strong hydrodynamic conditions that are very tidally driven. So in the past, I know with work that Barbara has done in that particular area, they've used tidal models to better inform what would be the best timing to put the RV in the water and recover. Last year we had the benefit of being able to just stick around a little bit longer. So using the other equipment pool on board, we were able to use the ADCP on the Rosette to kind of get a time series over like a tidal cycle of what the currents are looking like throughout the water column from the surface to mid-water layers in the bottom, and got a very detailed picture at this one site about how the currents develop, how they change direction, how they change in magnitude over the course of a tidal cycle. And then we're able to pinpoint a precise, hour and a half, 2 hour window that we could make it work. So it's challenging, and I appreciate the patience of the whole team to make sure that we can get the data that we need.
That was incredibly laborious, but it was pretty cool that it worked. Definitely, like in some of these sites, like even the best models are not very good. And so we had to like take our own data and figure it out. It was pretty cool.
And if I may say something on that, that I think it's interesting, the currents at that site are so strong that I remember seeing coral shivering. It's like you can see them in the water doing this sometimes. And so, it is a difficult site to work at, and I admit that, like we've been doing some work for the past, I think, more than 10 years and at that site. And I think at some point I kind of, I needed a pause. I needed to not go back there for a while because it was being so difficult to time our dives and to get, to be successful at it, that we just decided, okay, we're going to try to focus in a few other sites. But I'm glad that John is very invested in it. And like the example he gave about last year and spending time to understand the conditions better. That is really important. It's really needed because of this complexity of the ROV. And, that area is hard for other types of equipment too, but, for the ROV is hard. And I will say that, the strong currents is one example, but you might also have other weather elements, right? Your winds and just making, a deployment maybe a little bit unsafe, and then we can't dive. And, before ASTRID, we had worked with a different ROV in the Amundsen. And I think one of the used or maintained very often at some point. And so it was just breaking. And so we would put it in the water, and then there was some sort of issue with the cable. There was a kink or there was something, and then we needed to stop the dive. And I had so many experiences like this that I remember when we got ASTRID in the first year that we went with it, in the end, I didn't have enough jars to put my specimens anymore because I wasn't used to being successful so often at collecting things and keeping them. So it was all good in the end, but that side of a complex equipment too, right? How you do need the team, like Gabby's team, dedicated to it so that it can continue functioning and giving you the results you need. So I think these are some good examples of challenges, I think.
Whether it be sea state, weather, storms, and then in the areas in the Canadian North that we work, sea ice and icebergs can be present an issue. There's this really great communication between the ROV team on board and the Coast Guard crew, whether that be, when we in some circumstances need to operate on the margins a little bit. There's a lot of great discussion on how to, make sure that things can happen safely. And then in the middle of a dive, if something crops up, like, hey, an iceberg is kind of drifting uncomfortably close to the ship, we need to kind of maneuver. there's a direct communication between the ROV control room and the bridge, and you can make some on-the-fly adjustments.
You know, I'm sure in the moment, like we've talked about, challenges can be hard to deal with, but it's great to hear about them and to hear more about, you know, all the different considerations that um, go into effect and, you know, in order to get such great research and to have such a great, you know, research vessel and team. Just to kind of round us out, I was hoping, you know, we could end by if you guys can share, you know, something you're looking forward to in this next season, whether it's a specific project, if you're able to say, or if it's just, you know, you're excited to get to work on the vessel again, whatever it might be, kind of just looking into the 2026 summer season. What's exciting?
I'm excited to get the gang back together. I don't get to see a lot of our operations team in the off season. I love working with them. I'm excited to get them all back together and get out at sea and do what we've been preparing for all winter. And for me, I've been going to sea for like almost 20 years, and I love the environment of being out at sea, like being on an adventure, um, being on an expedition. I've just always loved it, so I've kept doing it. Yeah, I'm looking forward to it.
Following up on that, I think Gabby is right. Like I mentioned, you know, like 40 scientists and 40 Coast Guards, like you have 80 people in a ship, right? So it becomes a family. People are waking up and eating together and having lunch together and dinner together. So that is an important aspect. And then I think we have a pretty good team, and we are really happy to see each other again and to work together and to spend time together, right? So I think that is a fun aspect of it. I think for myself, I'm looking forward to going back to the area in Makovic and the Sentinel, these two sites where we know we have the presence of these cliffs full of coral. We're going to visit two sites that we have not visited yet, and I'm hoping the plan is that our predictions are going to work and that we're going to find another cliff full of coral. So that is always exciting. It's nerve-wracking too, but we're excited about that, and I'm excited to collect some really good samples. We have some new projects coming up, and like I mentioned, it's the possibility of using the ROV for those targeted, very specific samples that otherwise we couldn't use for the types of studies we are doing. So I guess that's that's the excitement that comes to mind first, I think.
Well, I'll echo just how great it is to work with a really close knit community on the ship. Looking forward to getting back on board, and then I'll just highlight really briefly a project that we're going to deploy this year that Gabby touched on. So we know that, you know, deep sea corals and sponges can live for, you know, hundreds of years, but we have more limited information about really young corals and sponges, the new ones, the babies, I guess you could say. How common are they in the deep sea? How frequently do they settle and then grow to a size that we can then detect them on the seafloor? So with Gabby's help, we had to design these kind of settlement collectors that we're going to deploy using the ROV, and they're going to basically act as a clean surface for kind of new corals and sponges and other benthic invertebrates to settle on. And then we can leave them for a number of years and return with the ROV a few 4 or 5 years down the road, collect them again, and then get an idea of what's settled. So I'm looking forward to see how that all shakes out.
Thank you all so much for taking the time today. I'm also excited to follow along in, you know, what you all get up to this summer. Best of luck with everything from, you know, weather to success of the experiments and whatnot. Thank you again for taking the time to be here and to share Astrid and all of your stories with us.